The lecture is about fluid mechanics. We are going to briefly discuss about basics of fluid mechanics, contents, fluid, properties of fluid. In properties of fluid, we are going to briefly discuss about mass density, specific volume, specific weight, and specific gravity. Fluid. A fluid is a substance that deforms continuously under the action of shear stress, no matter if it is small. It has no definite shape. Considering an example, a cup of water. Water is a fluid, it takes the shape of the cup. Another example, ice is being dropped into a cup of water. When ice is being dropped, the ice creates an external force which is an action of shear stress, and the water gets deformation on the surface, which is your deformation area. Fluid is broadly classified into liquid and gas. A water bottle with water. Here the fluid is water. It is a type of liquid. Next, a empty water bottle. Here the fluid is gas. Next one, a cool drinks bottle. It is an example where it consists of liquid and gas. Fluid mechanics. It is a branch of science that deals with the behavior of fluid either in rest or motion. Considering example, pond. Here in pond, the water is under stagnant condition. When you are going to study the behavior of water on this condition, then it is under rest. Another example, water is flowing in a pipe. When you are going to study the behavior of fluid over here, then the fluid is under motion. Applications of fluid mechanics. Motion of fish is an application of fluid mechanics. Circulation of blood in veins is an example. Water supply systems and oil pipelines are designed on basic of principles of fluid mechanics. Properties of fluid. The first property is mass density. It is denoted by the letter rho. It is defined as mass per unit volume, where rho density in kg per meter cube, m mass in kg, v volume in meter cube. The second property is specific volume. It is defined as volume of fluid per unit mass. It is denoted by letter v. Another formula is it is reciprocal of density. We know that density is equal to mass by volume, where v small v specific volume in meter cube per kg, m mass in kg, v volume in meter cube, rho density in kg. The next property is specific weight or weight density denoted by small w. It is defined as weight per unit volume, where weight is capital W and volume is for capital V. We know that weight is equal to mass into acceleration. Next, we know that mass by volume is density. So it is further converted into rho into G. W specific weight in Newton per meter cube, capital W weight Newton, capital V volume meter cube, rho density in kg per meter cube, G acceleration due to gravity in meter per second square, mass m in kg. The next property is specific gravity denoted by letter capital S. It is a ratio of specific weight of given fluid to specific weight of standard fluid, where specific weight is equal to mg divided by v for given fluid, and once again the same thing is repeated for the standard fluid. The acceleration is common for both the condition, so we can say S is equal to m by v by m by v. M by v is nothing but mass density. Therefore S is equal to mass density of given fluid to mass density of standard fluid, where S is specific gravity, no unit, W specific weight in Newton per meter cube, rho density in kg per meter cube, specific weight of water 9810 Newton per meter cube, density of water is 1000 kg per meter cube. We are going to see problems on properties of first problem. Calculate the specific weight, specific mass and specific volume of liquid having a volume of 6 meter cube and a weight of 44 kilonewton. So they are given two given data. One it is volume of fluid and the next one is weight of the fluid. First volume 6 meter cube. Next weight 44 kilonewton. Since it is being given in kilonewton, I am going to convert into Newton. Therefore, it will be 44 into 10 to the power 3 Newton. Solution. We are going to first calculate specific weight of the liquid. Specific weight is weight by volume. It is equal to W by V. We know that W is being given on the problem as 44 into 10 to the power 3 Newton and volume is 6 meter cube. On substitution, we get small w as 7.33 into 10 to the power 3 Newton per meter cube. Next, they asked us to find mass density. Mass density is given by mass by volume. M by V. So I'm not having the mass data over here. So I'm going for another formula. We know that specific weight is equal to density into acceleration. I have my specific weight as 7.33 into 10 to the power 3 and I know my acceleration as 9.81. So on substitution, I get density as 747.53 kg per meter cube. Then they asked us to find specific volume. Specific volume is given by volume by mass. So once again, I'm not having my mass data. So I'm going for another formula. Volume, specific volume is reciprocal of density. So substituting the density value, I get specific volume as 1.33 into 10 to the power minus 3 meter cube per kg. Problem number 2. Calculate the specific weight, density, specific volume and specific gravity of 1 liter liquid which has a weight of 7 Newton. Given data, volume of the liquid is given in liters. First, I have to convert liters into meter cube. For that, I have to divide it by 1000. So, V is equal to 1 into 10 to the power minus 3 meter cube. Then they are given capital W as 7 Newton. Solution. Specific weight. Specific weight is given as weight by volume. So on substitution, I get W is equal to 7 into 10 to the power 3 Newton per meter cube. Next, mass density or specific mass. It is given by mass by volume. Once again, I am not having my mass data. So I am going for another formula where W is equal to rho into G. So I know my W value as 7 into 10 to the power 3 and I know my G value as 9.81. Substituting it, I get rho is equal to 713.557 kg per meter cube. Next, specific volume. Specific volume is given by volume by mass. Once again, I am going for another formula. V is equal to 1 by rho. On substitution, I get V is equal to 1.401 into 10 to the power minus 3 meter cube per kg. Next, specific gravity. Specific gravity is density of liquid divided by density of standard liquid. Substituting the density of liquid as 713.557. Here the density of standard liquid is water 1000. So your S is equal to 0.713. Specific gravity has no unit. Your third problem. Calculate the specific weight and density of 1 liter petrol which has a specific gravity of 0.7. Given data, volume 1 liter, unit conversion. So divided by 1000, 1 into 10 to the power minus 3 meter cube. They are given your specific gravity capital S as 0.7. Solution. Specific gravity, S is equal to density of liquid divided by density of standard liquid. So they are given your specific gravity and we know that the standard liquid density is 1000. Therefore, density of petrol is 700 kg per meter cube. Specific weight. Specific weight is equal to weight by volume. So another formula is W is equal to rho into G. So 700 into 9.81. Therefore, specific weight of petrol is 6867 Newton per meter cube.